All right, I'm going to take you through the optional geometric approach to the completing the square technique. All right, so Babylonian completing the square, but with a focus on geometric applications. All right, so what's happening here when we solve, and you can go through this, I suppose, but what's really happening is, let me grab an example. I'll do this one. I'll throw a page. Is we're looking at the square of a value as actually a geometric square. So numerically, when we square a number, we multiply by itself, right? So here we're looking at it. Yeah, it's a number that's multiplied by itself, but it's also a physical square, right? So what I would do is divide every term by 2, just to get it in the appropriate form for the Babylonian completing the square technique. So x squared plus 4x minus, not 90, 45 equals 0. Then I would add the 45 to both sides. All right, so that's going to give me x squared plus 4x equals 45. All right, so what we're going to do here is draw a physical square. X by x. X times x is x squared. Right? What this is saying, if we look at this again in a geometric context, this is saying that we have the area of some rectangular object is equal to 45. All right. So that 4x, I can add on another 4 of those x's. Now, it's kind of weird to think of it this way. Let me just actually kind of show it off on the side here. So x squared is really x times x. So that gives us the area of a square, that is x by x. This other part is 4 rectangles that have each an area of x. All right, so this is really 4 times x. All right, so 4 of those x values. The problem is, based off of the scale, I don't really know what 4 is equivalent to. Like, I know 4 is the number 4, but what does that look like in terms of an actual rectangle? All right, so what we would do is we would establish some length to represent x. Fortunately, we already have that. All right, when I drew this diagram here, I essentially, without really thinking, I established that the length of x is going to be that distance there. All right, now it's going to be x by 4, right? But that's also the same as saying x plus x plus x plus x. All right, so we have the x times x, then plus another x plus x plus x, and so on. All right, I'm going to smidge this down just a little bit more. Each one of those can be thought of as an x by 1. So I'm going to establish some length that represents 1. All right, so I'm going to call this rectangle here 1. That distance, I'm going to just call that 1. All right, so I need 4 of those rectangles. All right, so if I could figure out the area of this rectangle, then I would be able to determine the value of x. All right, but the thing is, we'd end up kind of going around in circles because if I were to just actually find each individual area, this one would be x squared, this would be x, 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 and x, which gets us right back to the x squared plus 4x, all right? So what we're gonna do instead, so we'll have essentially the same figure. I'm gonna duplicate. But instead of throwing 4 rectangles onto the right-hand side of the diagram, I'm gonna instead move it around to the bottom. And of course I didn't make my dimensions equivalent, so I'm just gonna kind of pretend, I'll just hand draw it. All right, because I didn't draw a perfect square, so, and it's still not perfect. You would think, you know, how I have this drawing app, this really useful tool, that I would make the most of it, but there's some things that I still can't get a handle on. All right, so this would be, instead of x by 1, it would be 1 by x. All right, so these distances are all x. All right, so what I would then do is complete the square. All right, so physically completing the square. So I would need to know what this area would be in order for that to work out. So I have a length here of 2, all right, the 1 plus 1, and a width of 2. So that gets me an area of 4, all right. So I'm actually going to put this in here. These are my areas, all right. So what I would have here is, if I added it all up, x squared plus 4x plus 4. And then on the right-hand side, I know it's supposed to total out to 45, but remember the original equation was x squared plus 4x, well, not the original equation, but the one we were working with, x squared plus 4x equals 45. So if I add 4 to one side of an equation, that's not legal unless I also add it to the other side. All right? That keeps the new equation equivalent to the previous one. Then I can factor. Everything at this point is really, when I write it down, it looks like I'm just using the traditional completing the square method. But if you know that the way I'm getting that x plus 2 is because this side of the square is x plus 2, and so is this side, x plus 2. If I want to find an area, length times width, x times 2 times x times 2, no, sorry, x plus 2 times x plus 2, so x plus 2 squared. And then if I'm going through the process of solving for x, now it's just algebra at this point. I mean, the lesson itself has some shortcut formulas, but this is really at the heart of what's going on. And also, it's one of the reasons why it's an optional topic. I don't know, I've never figured out how I would be able to assess on a test whether a student understood this concept, because all of this work here, everything I just did, it looks just like ordinary completing the square. So how would I know that you followed the progression the right way? So it doesn't lend itself very well to an assessment like a test or something, but it is an interesting topic, so it was worth spending some time talking about. All right, but to answer the question in simplest terms, I guess, the question of, will this be on a test? No. Will it be on a quiz? No. All right, it's learning for the sake of learning.